also go over, yeah, just to give like everyone a bit about what I've been thinking, but I think for this to be a bit more effective, someone else should drive when looking through the GDA code. So that, yeah, I don't know if that makes sense, but we'll try it out. So just gonna go over the contents, just start with a high-level overview, go over some of the invariants I've thought of so far. Just thought of this for like a few minutes, so I haven't thought of it very, very deeply. There's probably a lot more variants. I'm going to go over quickly some of the testing that I've done for this so far. And that's, fuzzing on the pure encode decode functions, as well as the setters getters, given the last session where we explained how we have these encoding and decoding functions to move I guess, like format the data so that it's able to be put into the super token. And then we also have setters and getters, which are used by the token monad abstract contract. So the idea here is that if these functions are working as expected for the full range of values, then it's probably fairly safe here. Then I'll go over some GDA and Superfluid tool specific integration tests and NFT contracts. And some of the assumptions that I currently held so far, next steps, and then some of the things to focus on when we're looking through the code. So high-level overview. Pretty sure this is familiar with everyone, but the entry points of Superfluid to do anything with agreements is the host contract. So you do call agreements. And these agreements are permissioned by the host, and the agreement contracts are the only thing that can modify the super token state. And GDA is no different, so everything is still exactly the same in this way. So there's a trust assumption that the agreements are correct. So everything that touches the super token state from within the agreements must be correct. And the host, there's also an assumption that the host contract is correct in the sense that we're sanitizing all of the inputs in there, and that we're handling context and all that other stuff correctly. So far I've only come up with these 3 invariants. Some of them are pretty similar to the other global invariants, but I think when I'm using Echidna later to do the invariant testing, I want to just make it just specifically for GDA, and hopefully it'll be written in a way where we can expand it so that it would run GDA, IDA, and CFA actions, and then still assert all of these invariants to be true. So the first one is that the sum of all of the users units should equal the total number of index units or pool units. It's typo. The sum of all GDA net flows should be equal to 0. Question is whether this should include the adjustment flow. I'm not actually sure, but that's something we can go into a bit more later. And the sum of all GDA real-time balance should be less than or equal to super token total supply, assuming that the GDA is the only agreement.
Yeah, so the net flow thing should be 0, yeah, including adjustment. Adjustment flow is nothing special from the surface of it. It's just internal mechanism of the thing. So if you look above, it should not even notice adjustment flow by the concepts. Yeah.
Okay. So yes,
at least by design.
Okay. Yeah, because I was thinking if we, because we do store the adjustment flow somewhere else and not in the same place as the other net flow, but yeah, we can look into this.
But when you get to the get net flow, it's accounted for. That's how it reconciles. I think in the toy super token, I do have a variance check of that net flow is always 0 in all cases. Remember, we tried to fix one bug, right? So that's kind of it's exposed through the get net flow function. So so by design should, and hope that part probably is not the shared logic. So I would hope that the GDA part is done similarly.
Okay. You can check that after. I'm not 100% sure, to be honest. So it's good.
That's a Echidna, perfect Echidna.
exactly. So yeah, like I said, we fuzzed the setters and getters with the full range of values, at least we're trusting that Foundry uses a decent sample of values from the range that we're giving it. So like a UNT 96 or the int 96 would be like minus whatever the max that is, and then plus the max. And we have a variety of test cases for GDA and Superpool, just revert and happy path cases and ad hoc stateful fuzz. So this is basically doing what Echidna will do more properly, but we're just looping over. We have an inputs for the fuzzing test where it's an array of structs, and the struct provides a bunch of random values, and these random values will determine which user is executing the action, which action it is, the amount, if it makes sense to have an amount, and all this stuff. And I've also tested the new NFT contracts. I don't think it'd be that useful to go over that looking at the test code. I think it's more useful to look at the implementation later, but someone else can try when we do that. And so the overall assumption is that given that we've properly sanitized and disallowed certain user inputs, and that the setters, getters, encoding, decoding work correctly for the full range of possible values, and that this full range is correct or complete enough, and the semantic money library worked correctly. And also we haven't, there's no unconsidered EVM quirks, reentrancy, counterfactual address, other unknown unknowns, then the invariance should hold and that the code will be secure. There's actually one thing I mentioned to Meow, but I don't think it's a big deal. It's basically, we currently do not want superfluid pools to be able to hold units, but you can actually find out the address of a superfluid pool before it's deployed or created. So you can send units to that account or assign units for that account before the actual pool creation, and then create the pool after. But then the worst case scenario there is that you've just wrote yourself and decided to donate or lock or freeze some funds in that pool forever. So it's not a huge deal, but something to consider. And so I think the next step, as we all know, is just to fuzz GDA using Echidna, run proper invariant testing there, just to catch anything we might not have considered. And I think when we go over the code, the best thing to do is to look at the do effects when we're in the GDA contract. And then in both contracts to see if there's any missing checks or input validations, and any other invariants that should be covered but aren't. So this will probably come after, more naturally after we look at the different functions and what they're supposed to do. Okay, so I think I want to do this a little differently this time. So I think someone else should share and go through the code, and we can all just observe. I don't know, what do you guys think, if that makes sense or not?
Is that how you want?
I'm wondering if that might be more effective than me guiding, because I might be guiding it in a certain way.
Yeah.
Yeah.
Okay, good idea. So better to be not me and you, because someone share the screen. Go to the
You're
code.
biased.
I'm very biased.
Yeah, exactly. We'll both be more biased about this, but if and we can just point out like the functions, right? There's like create pool. I mean, just
Will I
Anyone?
do it?
Yeah, go for it.
Do you think it works if I have it open just in GitHub, or should I check it out?
I think it'll be easier to read if you check it out, probably. Yeah.
Give me a second.
You can even use code spaces, maybe.
I will not figure that out now. But work tree maybe would be useful in such a moment. GDA. Yeah, share screen. Okay, first, yeah. So should I start here?
Yeah, just go over it the way you would, and we can, I guess, look at the different functions to see if anything is missing. I think that's probably the best way. We want to look at GDA and then the superfluid pool after.
Oh, this is from a different track. Okay. Yeah. So the proxy is done here. So I guess we have the usual constraints with keeping the order of the slots.
Yeah, I don't think we have any
Oh, there's
specific storage.
none. There's all
Yeah.
constants, right?
Yep.
Mhm.
Oh, no, I lied. There's one beacon below the structs.
This one.
Yeah, that should probably be above the structs,
Okay.
or the struct should be above or something. I don't know what the correct convention is for that.
So these are friendly for packing. First, second, third word, I guess. 1, 2 words. Yeah, this ugly background.
Well, we demonstrated either this or 10 times compiling speed. So pick a poison.
Yeah.
Yeah.
Yes. So here we just remember the host. Initialize, okay, this we discussed last time, but now it's beacon. Return balance vector add. So this is from the I agreement, right? No.
The real-time balance of is from
Return balance
the,
of.
yeah, that should be from my agreement.
Yeah, so since you are here, I just mentioned something we talked about, have a big overdue of the formatting, right? So I think after this merge, we could think about it. The only thing I didn't quite like about the Foundry formatter is the some of opinionated part. I don't know if I can configure it away. Some little details, but otherwise, I think we could do is that after the review. For example, if I do manual formatting myself, I would sort of public view override will be in one line, right? Didn't really make sense to have.
Yeah.
You know, if
Yeah,
each one
also-
line for the auditor is 10,000 euros, so probably.
I mean,
Yeah,
if we wanted this to be on one line, we would just have to increase the line length.
no, that's not a problem. Those three nicely fit. Even all of this would fit into one line and still not exceed the maximum line.
Could be a separate line
right.
in one line. Right? That's what I would do. Anyway, so this is not important. I'm just saying, since we're here, I just want to mention it, that we will do a big formatting exercise after the demos to see if we can have some reasonable default format done by tools, but not now. It will create too much conflict in the code.
Okay, so real-time balance of token account time. The first real-time balance vector at what's vector here? Where's index data? So why does this encode? Is it in order to get bytes? I guess in order to get this as bytes, right?
Yeah, exactly.
So token, that's not malleable, so I don't think you can trick into pointing to another slot here. Index data. Is that part of the semantic monitor? By the way, do you guys know, I still didn't spend the time to figure out how to be able to jump in here. That's something which used to work with WebStorm, but in Visual Studio Code. Because I guess it would make sense to look into it, or do we treat it as a black box now?
Yeah, so that's a good question. I can't jump into it either. It only seems to be able to do it for contracts that are in the same
Same
like
project.
Absolutely.
Yeah.
Yeah, but sometimes it works. I don't know. It's weird. It's not a very good answer, but yeah, sometimes the like Open Zeppelin and stuff, you can actually click into it.
Okay. So what do we, I mean, yeah, because if there's no introspection, it's probably a bit difficult to analyze this code. Could try to open it in WebStorm. Okay, let's try like this. So basic particle from U index. And this is all typed, so we got if this pull token uploads. What is this doing? It's connected balance. Okay, so it's saying if I check the balance for a pool, then
Yeah, then the available is the disconnected balance for that pool.
Yeah. So here has one thing we talked about, right? If you assign units to a, yeah, there was a fancy word there for like the what's the word? Counterfactual. So before the pool is created, you can assign the units, right? And here, this specific optimization actually is in a way now. Actually, I just realized. So the idea is that if you are pool, remember the analogy? Oh, the screen goes black.
Yeah, it's black for me too now.
What's going on? Are you using Arch Linux still?
It's Ubuntu. Seems to be a Zoom bug, or I mean, Zoom.
Yeah, I see my own circle now. That's fine.
I could try to share the whole screen. Maybe then it works. First, I need to need something. Can you delete this?
Oh, I deleted.
Oh, that's okay. I don't see my screen.
Try to reshare.
I can't share either. Broke my canvas. I tried to restart Zoom.
Yeah, just restart sharing maybe.
Okay, I managed to close it. Yeah, we try with WebStorm. I know you don't like the color, but get over it. So oh no, it's the same. Now, did you draw again, or did it just do it itself?
Yeah, I guess whenever I want to draw, your Zoom fails. Can you just stop sharing and share again so that I don't draw again? I just talk over it. Can you stop sharing? Oh, no.
No, I don't get the controls. I need some money to get it.
Maybe Meow, you can close his sharing as your host, right?
Yeah. Oops.
Okay, yeah.
Okay, so what do? You have to share again, but nobody draw, okay?
No, you're the only one drawing, so
Okay.
don't draw.
All right, just share it. Okay, cool.
So what did you want to show?
I'm just saying that can you go to the line again in the real-time balance? Yes, so that's the line. So the idea is that when you want to know the balance of the address, right? So there are two cases. generally. If it's a pool, the balance provided by the pool, right? So you imagine pool as a sort of water tank. So if it's distributed away to the connected members, then you don't get to know, you don't get to accumulate those balances. So you have to use the pool function called get disconnected balance. Hopefully that's kind of intuitive, right? So think of a water tank. If it's disconnected, it would accumulate there. So that belongs to the account, right? Although the balance concept, right? If you use that analogy, physically it kind of belongs to the pool, but accounting-wise, it belongs to the account that. Oh wait. Actually, it belongs to the pool. So, so that's one case. The other is that you simply query the balance provided by the universal index, which is probably complicated to explain here without going prior explanation. But there can be a case that you want to have both, right? So the correct implementation is you should plus them together. So you query the disconnected and plus the other one. But in this particular implementation, reference implementation is the same. They are separated queries. I think it's part of optimization because usually you are either a pool or either you are not a pool, right? So there's no connected, either you are a kind of non-member of, how do you say? So this would not work if the pool can have another pool as a member, right? And that situation can be created with the this counterfactual membership, let's call it. Shall we call it counterfactual membership to scare people?
Yes.
Okay, good.
So what would be the outcome that that sum of all real-time balances doesn't?
Yeah, I
match
think invariance would break. I think we can actually create that scenario because this particular calculation, the fix, either we ignore the problem, which is probably not nice if we want to actually continue to monitor the invariance live situation. But in effect, it doesn't matter because the money is simply lost. Right? But we, the semantic money version of the balance is that we want to sum up everything and everything should be zero, including the mint account, which will be negative balance. That's just conceptual claim, but in practice, that doesn't provide more value than being able to verify the correctness in life. So we can debate about that.
Wait a second. The check here.
Yeah.
This pool token account. Token account.
Yeah.
So because the units belong to a specific pool, right?
Yeah.
So the scenario you are describing, aren't those units of a different pool, which does that matter here? Because then
you're right. Actually, maybe actually, the next block where we haven't go to the next block, right? If you see the next block 147, that's the block that you go through all the connected pool for the account, and you tally all the balances of your memberships, connected memberships rather. Right, so you go through the slots IDs, right? So maybe here we can mention that the pool connection IDs is implementation of the slots bitmap, which we use in IDA also. So if you have up to 256 hard coded for now, you can tune it for sure. Or you have 256 membership up to, and you go through all of them and sum of the balance up. So so forget what I just said 5 minutes ago. So that's not a problem because when you are pool, nobody can send you balance. So the universal index accepts transfer or instant transfer or the flow, right? But if you could stack this position and jump to that transfer function, probably in this one. Is there instant transfer function? How it's called? The one that does 1 to n in this.
Oh, yeah, yeah.
How do you call it?
Distribute.
Distribute, sorry. If you go distribute, there's a check. So if it's a pool, it's actually revert. So that situation never happens. That's why the if else is okay. If that makes sense. I think we lost DD.
Okay, again,
No?
no,
Yeah,
I'm
if you
here. I needed to restart. So where should I go?
Distribute the same file. Distribute function. Yeah, so there should be is pool and revert GDA only super token pool.
Yeah.
I think that's wrong though. It should be equals to true.
Yes, wrong. So if equal to false, yeah, that's wrong. No, that's right. So the idea is that you cannot. Yeah, it's correct. So you shouldn't do an instant transfer to a wait.
Other.
No, okay, I see now. So the correct. Wait.
No, this is correct. So this is saying that if you are the address that you passed in the pool
Yeah.
is not a pool, then you revert. You're only allowed to call distribute on pools. So yeah, but it's not saying like you're. Yeah, this is fine. Yeah, I looked at it for a second. I was like, wait a minute, how did I make this such a silly mistake? But no, okay. Because I have tests and everything. It's like, how did it pass? Okay, no, this is
Yeah.
correct.
Yeah. Oh, yeah. Sorry. Didi, let's follow your brain logic now. Go back to real-time balance. You can ask any questions.
Yeah.
Yes,
Yeah,
sir.
I'm still thinking about this. If how we should treat this. Because
Yeah,
we
so
didn't, or did we solve the problem?
And there's no problem.
There's no problem.
No.
So, okay, what happens if I say, I did send units of a different pool, but of the same token to this address before this became a pool, then became a pool, then I do this check, then it's.
That's not affected because when you are a pool that has units, because a pool doesn't have action of either approve or either claim, so those balance will stay in the other pool, the one that's giving the.
So
yeah.
So it would
So-
just go here and return the disconnected balance, and the other one is always 0 anyway. So, okay, so that's the solution, right? The real solution here.
it's not a
Okay.
solution. It's more like it's just like you're throwing your tokens away, kind of, right? Because you
Yeah.
give full units and then you send it to there. Yeah, you're just
So
you're burning it.
they forever remain. So accounting wise, they forever remain in the disconnected balance of this other pool they belong to.
Yeah.
And there is no way to send the pool's own units to itself before it exists, because then the units also don't exist. I guess no, that's not possible.
But I guess that does mean that a pool of a different token can send it, but I guess that's okay. Same thing happens though. Same thing happens.
Yeah. It's a own, and it's not super descriptive.
Yeah, I
You
should
can
change that
balance
to
itself.
available.
So here it would. Here's own. No, here it's RTB. Buff or buffer. On from this buffer. So why is this named vector?
It returns 3 balances, or is it your own balance, the balance from the pool, and the balance related to the buffer. And
Okay.
so it's a utility function used by the real-time balance off, which is overriding the base function. Public view.
I think what's a bit
Sorry.
confusing here is that the real-time balance off returns one balance and two other things.
But that's the
Well,
interface we're stuck with.
Yeah. While this returns three balances.
Yeah. It's because of time and maybe
Okay, let's not.
so the I guess we want to see the security related
Yeah, so I think
concerning. Yeah,
go-
where
go-
do you want focus? Yeah.
So
maybe
shall
jumping
we
down.
skip this? Okay.
Yeah, we can skip the view stuff for now. I think more of a concern is the state modifying ones, like create pool, connect pool, distribute and distribute flow. Those
So this
are the
is
main ones.
view
Yeah.
functions. Okay, this is not view. Wait, pool. Token admin. So what happens if I do create pool with a non-super token?
If it's not a super token, but it still implements update agreement state slot, then it's fine. But if it's just a random token or random address which doesn't implement it, then it just will revert. And I guess in the case that you do implement this anyways, you're only going to be affecting that token's agreement states, or you're going to be only running the code from that address. So there's no issue there, I guess. But then you do create a pool.
So what is the contracts? The contracts which states this contract can modify. So it's the tokens contract. It's the pools. Okay, here let's see. The pool is created, and then just takes a pool argument. Okay. So those methods which take pool and token.
Yes. Okay, so actually you do bring up a good point here. Right now, if you create a pool and you pass in a token that implements all the correct things, you can create a pool, basically. I mean, what is that an issue?
There's nothing nasty I can do with that pool, which affects other
Yeah,
tokens
exactly.
too.
So the pool, you have no control over exactly what the pool contract looks like currently. When you create the pool, it's specifying the token, the admin, and then the logic contract or the beacon, I guess, for that particular pool. So all of the actions on tokens are going to be for that particular token. Should not be for any other tokens. That's, yeah.
So this is there's 20 interface. That was
Does it have the extended approval interface implementation, or it will stick to the like increase decrease allowance? Is that part of the interface? Yeah. Okay.
Yeah.
What's the recommend?
Yeah.
Do we even remove the old one, or old one is not a problem? It's more of a usability issue. I think it's not really a problem apart from usability issue in some cases, right? Okay.
think so, yeah. Plus, you kind of have to have it, right? The approve for the standard or no?
Hmm. But the new one's a superset, right?
Yeah,
So you don't
superset's
have to use
okay. Oh, okay.
So here it calls into the GDA. This member connected. And this dot pool member data. It's from the token. So that's just a connected
Yeah.
token.
I think most of the calls to the GDA, actually all of them, if they are taking a token, it'll only either view something specific to that token or update something specific to that token. So there's also like append index update by pool. This does set uindex, set pool adjustment flow rate, but for that token and pool. There's also a pool settle claim function. And same thing, we're doing shifts, but we turn the token into bytes and
Okay, so here. So admin and token are provided from outside. They're both addresses, but they are just set here. Admin. So if the token dot if this re-enters, can it do anything nasty? So at this point, the pool was created. And then it does token dot update agreement state slot, and this code could actually re-enter and try to do something. Can I do anything bad with the pool already existing?
it can.
That is not gonna do any re-entrance. How that doesn't call any callback. It's
Well,
just storage
a malicious one can. Malicious
Yeah,
one can
this
call whatever
yeah,
they want.
a contract can call whatever they want. They could call this create pool again.
For example, I create pool maybe doesn't make sense, but they could pretend the pool already exists, because even though this create pool hasn't yet finished, the contract does actually exist at this point when it could re-enter. But again, I guess you can only break your own pool. So even if you somehow distort your own pool, that shouldn't affect any other tokens. So
yeah, I can't see any way of getting into another token or pool from here at least.
what does this do?
that return, that's maybe bad naming actually. That returns the whole admin NFT address. Yeah, it's really bad naming actually. Yeah, let me change that.
Okay, it's got, that's just from the document. We create pool, then connect pool. Connect pool. Um, isn't this weird to overload but have different order of the arguments? Or is that okay? I mean, technically it's okay, but I'm not sure if there's a convention. Okay, but security-wise shouldn't matter. So that's the token. The sender. So connect pool says I as a message sender get connected to this pool, and I can write CTX I provide, but that is checked here. This is
Is there any reason that this branching is implemented this way and not in the separate methods? Like to do connects, Boolean? Because it's used for disconnect, right? So you pass true or false.
You're saying why this isn't in like connect pool, what, and
Mhm.
this bottom half isn't.
Reuse only, or
Yeah, I think freeze. That's probably the only way I think about it. Yeah.
I think this should be renamed to something like set pool connection status or something like that.
Yeah, okay, that's true. That's better naming because it's a bit misleading otherwise.
Should this be public?
It can't, I mean, there's no harm. Because the only thing that you're changing is the do connect, which the two connect pool, disconnect pools are doing. But if you think there is.
Now, what is our policy? Because I think you generally try to avoid adding something to the public interface, because then it's kind of a long-term commitment to keep it like that. So I feel like we should.
In this case, yeah, splitting hair now. I'd rather not for now. It was copied over, I guess, from Toy Super Token. I guess there are same name as one's connect pool with flags. If you want to split hair, there's certain API design I've seen that they have this, which is I think naming wise is for sure can be confusing if you don't focus on that. Yeah, but otherwise it is not confusing in the sense that you don't need to remember another combination of English words. It's the same name with one more flag. That's overloading. Right? That's one of the reasons I see some of the overloading function design that they do that, not from the angle of spelling and English meaning per se, but from the sense of just remember one combination, but with different flag data. So, we're splitting hair.
Yeah, that's my issue with the naming, that it's actually semantically it's not related to this one. It's
Yeah,
kind
I'm
of
just telling you that
subset
why
of
from the
other
other angle, why it could make sense for some reason, other reason why, because this is I didn't even think about it when I did it, because that's just how some of the API I've seen that they do that. Otherwise, I don't see that's often used one, right? I would expect people mostly use the connect pull and disconnect pull more explicit, which want to call. The third one is if you want to do away with if else, right? So from the so from the on-chain or off-chain perspective, if you want forcing true or false semantic, instead of calling two different functions, use a third version, which is then we talk on the naming. So that to your question, yes, I think that should be public, because that's kind of the one of the use cases that you don't need to know what's the current status. Is it connected or is it not connected? You just want to connect with a flag. Naming wise, what can I say? There's no standard here. I don't know if I guess we're not keeping notes here, right? So, but I would keep the security notes rather. So this one could be a side note. Hey, the naming of this is causing a little bit of pause, but
Yeah, I
don't have answer for that right now. Yeah.
Okay. So the same thing with malicious token could re-enter, but we don't care.
Yeah, we could make notes there. That's definitely a good security notes that we don't generally. Okay, the way about security boundary analysis in general, this is where a security boundary is. We don't trust token, right? So formally say the boundary, security boundary is that whatever we call here, we don't trust. So if we don't trust, what kind of damage can it cost? First of all, there's EVM level of protection, because we're not using delegated core, so it's external core, so the storage is protected. But what's not protected is the re-entrance, right? So we should assume that this one can call some other logic back. And is that gonna cause any damage? Not this one, right? The previous one, I guess. But this one can also. Right?
Yeah, this one also. Basically everything doing token dot something. But it can damage its own state and the pool state, I guess. But
so what we can
is isolated against each other.
Yeah, so what we can check here is what kind of state of the GDA we are talking about here. So here we check the pool connectivity, pool existence, right? That's one of the state check we do. We check if the pool is already registered. And that's one check. What else? Oh wait, there is a membership connection. Yeah. Is member connected? That's storage also isolated for the
for that token.
yeah.
So yeah, I guess with all of these functions are doing token dot something. As long as that code cannot jump into another token's code, I think it's okay. I mean, it's okay because like they're just going to be messing up their own token.
Yeah,
but it can jump to other tokens code, but it's just there's no direct interactions between two tokens. They're kind of isolated, right? There's no kind of logic say, hey, this. Well, there's no callback yet. All right. So
how do you mean it can jump to other?
Like you can in this token dot create agreement, you can do something with another token's like do another GDA function on another token, but you haven't done anything before that to change some condition on that other token to do anything meaningful. So for example, you can go inside token.create agreement. This is like my malicious token, but then I'm in create agreement, I'm jumping into creating a pool for USDCX or something, or doing a
Yeah.
flow distribute or something like that, right? But
Yeah,
if you
yeah,
haven't
true.
changed, if you haven't changed anything about that token, the other token inside of here, then there's nothing you can really do.
Yeah, but yeah. In that case, you
Right,
don't have
yeah.
any privileged access. You start from
Yeah.
here like any other, yeah. That should be okay. I mean, it's also not different in other agreements. Wait, what did I just? There was
We run connect pool.
something else I just wanted to mention. What was it? Ah, yeah. So I guess a fuzzer would try that if token and admin are the same address. Anything funny I can do with that? I mean, I guess I could have a token contract which also has logic for being the admin, but
I just want to say
guess-
that the fuzzer don't really automatically do that, right? So when we set up the occasional test, we have to make sure that it has enough search spaces. And this is one search space that you don't get it for free. We're not doing constraint solving like the model checking or Z3, this type of thing. So not all the mathematical condition is checked, right? So in this case, setting up fuzzer still need to be a little bit more thoughtful. Right. So for example, if we don't test the dual token, right? I think having 2 tokens in the system versus 3 probably don't make much differences, right? So having 2 is already a lot of search space more than just 1 token, right? So that's something we need to set up deliberately. So fuzzer is not magic, right? You have to set up the base search space first. So that's actually
I would, however, expect it to include such a special case. Because
there's no magic. There's no magic. You have to do it yourself.
No,
So
but that doesn't require magic. It's I don't know. It's
You're saying like
it's
as a
kind
base
of
case, just putting the same random address in the same random address. If we're I guess and like
just like when you have when you have numeric types, then they will by default test boundaries, so something like that.
Yeah, but in that case, when we do the echidna one, we will see exactly. Even with Foundry, when doing impersonate, you have to select a set of address, right? So that set has to include these kind of special cases. If you don't, you wouldn't have that case. So there's no magic per se, but it's fairly a small step just to include everything, including token itself, right? Being admin.
Here, CTX is only for getting the message sender, right?
Yep. And authorizing, with the authorized token access. Yeah.
Index update.
Yeah, what does this mean actually?
This is called when you update member units and you're appending the index update to for the pool. Like you're updating the universal index of the pool here. I'm appending monoid appending the basic particle. You're basically combining the change in units state for whenever the update member units is called. I think that's what, let's double check. Pretty sure that's where this is being called from.
Update member units.
Yeah, so it's update member units, and basically the bottom one I know for sure. So set adjustment flow rate, that can change. So we update that. We pass in the basic particle, which is just the output of updating this pool members units. And we're just updating the universal index of the pool here and to append, and I always forget what this function does, but it sets the current settle at time. It adds the settled value of the previous, what it was before, and then what it is now, or what was, yeah, what it is now at this current time, I guess. And it also adds the flow rates. So if the flow rate needs to change here, or the settled value needs to change, it updates that when update member units is updated. So the basic particle is composed of, I think, 3 things. Just check.
So wait a second. This is external, and
Yeah,
this is permissionless.
yeah. I guess it's in the permission is in the internal, but maybe it should be external. I don't know what the convention is.
No, this one is external.
Yes.
Yeah, I think permission control should be in the external. Yeah, that's definitely the better convention. So can you double check that the permission control is always in the outer layer? The internal is for just the main logic. You delay all the permission control to the outer layer as much as possible, so it's less confusing. Because when you read the code, you would expect the permission control comes first when you read the external, right? So
Yeah, that does make more sense.
Okay, so this can be invoked only from a pool contract, correct?
so the naming convention, I think here is that by pool, meaning that the only pool can call it, right? So there's a collaborative sense that the pool and the GDA work together to manipulate the balances. And the only function that allow you to do that is this particular set of function called a by pool.
So here, if wait, there is pool. How does that work again? That
It's
looks up
pool.
a registry, right?
Yeah, so when we create the pool, we set it in the registry just to say that, okay, this address is a pool for this particular super token.
And where is the registry?
If you scroll all the way up, there should be, yeah, information about all of it.
In the token?
Yeah, in the token.
GDA itself has no storage almost, right?
Yeah.
Yeah, same as GDA.
Yeah. Mm-hmm. And registry, yeah, good. That's kind of still the design, that token data ownership thing. So we're GDPR compliant, right?
So a malicious token, I guess, could actually mess with other pools accessing it. So it could pretend to be a good token and get some adoption and then steal from other pools. I guess that's something which could be possible. But then again, it harms itself. So maybe not such an interesting scenario.
Yeah, because to other, I'm just thinking, right, to other tokens, the pool membership means from the other token means nothing to the other token, right? So
yeah, no,
so
not from other tokens, but it could. You could mess with other pools,
right, but you can't.
Of the same token, I mean.
Yeah, the pool address is deterministic in the sense that it's determined by the token, right? Token is one of the inputs. So, yeah, worth thinking a little bit. But I think you can't just get the pool address however you want, unless you can mess with it. That's probably what you want to say, right? So, can you get a pool address as you wish? From the logic here, I don't see, because it's simply a new token. So it's dependent of the nonce of the contract
Yes.
itself, address of the token. So it's a bunch of hash already.
Well, I guess here it's deterministic based. How did this work on the sender address and nonce regardless of the contract? I
But
think
this is
that's
not
how the-
outer layer. You have to go before, right? Or is it? Wait. Oh, this is one that if you go back to previous one, I'm just reminding myself. Is it called dot deploy? Where is
Yeah,
it? Which
very
one?
cool.
Oh, dot deploy. Okay, 274. Yeah. So that one is determined by. Yeah. So the library.
just the nonce of that.
Not the
Yeah.
GDA.
So initial core data is part of the hash also, right? So the core data is also part. So that includes admin and token and the beacon proxy code itself. Yeah, so everything mixed in. So you don't get to mess it up as far as I understand. Or you can try to mess up with a hash collision, but we're not talking about that kind of case anymore in this context.
So where were we? Append. Okay, malicious tool we can't really have. It's predefined code. And through the pool, is there any delegate call to arbitrary code from the pool? That's not.
No. Yeah. Well, it's proxy. So the delegate calls to the logic whenever you're doing something first, but not from the pool to something else. No. I don't think so. I mean, you have to explicitly do a delegate call, right? Yeah, we're not doing that. None of that.
With the order is strange. So here the external is first, and here it's after what? Who settle claim? This is again by
Yeah,
pool
same thing.
logic, right?
Yeah, and I removed that over to the external as well. The check to the external, that is.
So again, this pool. We really need to be careful to never allow the store at an arbitrary location in a token. So to never allow a code path where you could store a piece of data.
Mhm.
Bullshit.
Yeah, that's a good point. We can double check, but I think the at the top of the GDA, the IDA, and the CFA, I mentioned the storage layout for the data we're storing, so we can Look at the async, I guess, just to be 100% sure that they're all in different locations.
So this is,
Can you wait? I'm just pausing a bit. I never checked the bitmap stuff yet, bitflag stuff yet. The is pool, how you implemented? Is pool, what? Checking the token and account. What is account? Oh, the account. Okay, yeah. Then you shift the 2 to 4, go another 2 to 4. Why you shift to 4? What is 2 to 4?
We're using the same same word for, let me find this,
Yeah, so you have a
universal index. Yeah,
yeah. You have a map somewhere. Okay.
because previously we had like another word for just for this pool, and it was not very economic. So this is just putting it in that particular location of the full word, and then instead of giving it its own.
Okay. Where's the computation for that? Oh, I see it. Universal index of is pool is 32 bits. I think this one we discussed this. Okay, cool. Right. I'm gonna have a review of that part of the stuff. How you do it? I don't know if the test is sufficient even. Okay. Let me think about it. Go ahead.
You probably want without underscore or
oh, this is a big number. I'm checking if the layout allows to have some kind of overrun into another address space, because it's basically address spaces we are creating here.
Yeah, no, it's the token storage design is similar to the solidity mapping, so you don't get to overrun. So when you do, for example, when you do a mapping from int to a big structure even, right? They don't get to overlap because they just point a random space in the, not that random, but
Yeah, but
a
here
point in.
it's, but these are just one word, so wait, why this number? But okay, this is hashed with the GDA address, right? So even if it's the same in a different agreement, it would still not point to the same slots. Is that correct?
yeah. So if you look at the, I think if you do create agreement inside of Superfluid token, you hash the string agreement data, the agreement class, and the ID.
Yeah.
And in this case, the ID is the hash of message sender and pool.
Distribute.
Yeah. Oh, but that's for something
No,
else.
okay, this were the
Um,
subject line. Distribute. So this is again external. And I provide token from pool.
Sorry, the thing that you were mentioning before is at the very bottom. The 1-1 left shift 128 is for find and fill connections bitmap. So if you look inside of at the very bottom of the contract and you look at slots bitmap library, that's how it does it.
Find and fill. Mhm. I guess that iterates. Cool.
Mhm.
Yeah.
So as long as that one doesn't clash with IDA, should be okay. Number. I don't know.
So
It's the
again,
same.
check if it's pool. Find context message. So no no initial possible here.
No, not currently.
Very simple one. A bit slow. So it's basically the same, but so it's still with mount. Again, tool sender. Check. So here, if requested amount is 0, will it just revert or succeed anyway?
Sorry. Requested amount is 0.
Yeah.
Let's see, what's the amount? Should we be a pool?
Yeah, but either way shouldn't be relevant security wise.
Yeah. I actually did notice something what you brought up. I think actually this pool connections data state slot ID start is not good because it's the same as IDA, and I'm looking at slots bitmap and the way it's implemented, it doesn't take into consideration the address. So that should be
No, the agreement has its own state.
I
Yeah, agreement, it's all namespace by agreement. Agreement don't conflict with each other. To check all the storage space are namespace agreement, then data type account and list. Agreement class.
Yep, never mind. It's message.sender is yeah, just kidding.
Yeah. Very funny how namespacing is done. You just add one ingredient in the hashing and somehow
should be
you
different.
magically have a new scope. Randomness is such a great concept. Okay, distribute flow. Get the old flow rate. What do I need to put flow rate? Just nothing. Flow distribution hash. So that's the kind of ID, right? Kind of a flow ID.
Sorry.
The hash is identifier of the
Yeah.
flow.
Yeah, yeah. From to the pool. For that token particular, I think should be.
Makes sense here. So, this is the case for liquidation. If we press the flow rate positive, then yeah, it's not allowed. So you can just set to 0. Well, you could actually have a negative one. No, that's excluded here. Real-time balance. Sender. What do we have? Liquidate address. So what is this again? That you index data.
Yeah. The universal index is just the translation of semantic money basic particle, plus also is whether or not the account is a pool or not, but
Is it the balance?
yeah, it holds the flow rate was settled at timestamp. It doesn't hold the balance, but flow rate settled at timestamp, the total buffer,
Okay.
whether or not that account is a pool, and also settled value.
Yeah, that describe a single account universally, right? So
yeah.
For a single account, you always have this universally available index.
Yeah.
But for a collection of account, you should be part of. You can be part of the proportional distribution index. Right, so as a receiver, you can be part of that. So you're just proportionally one member of that index, and that's stored in the pool, I believe, no? And then you can query the balance. That's how you query the connected balance or something. Okay, I might be missing something, but that's something like that. So that's what the index is about. Yeah.
So it's as before, if the account has an available balance of 0 or of 0, then everything outgoing can be liquidated, be it CFA or GDA. Make liquidation payouts, not V2. Is this one? No, don't we have V2 anymore? Or no, that was in the token, right? The V2.
Yeah. So
correlation
inside
thing.
this, it will call liquidation V2, I think. Liquidation. Yeah, if you look at down there, yep, right there, make liquidation payouts V2.
Yeah, this part of logic. Scale.
I mean, it's the same as CFA. But
Yeah, for CF it works. I'm just saying that for GDA we didn't do any modification, and that's where I think I'd rather we stay with it for now.
Is it completely the same code?
Excuse me?
Is it completely the same code?
oh,
Yeah,
pretty
it's
much.
reused.
Yeah, it's not reused. But the past parameters are the same. But yeah, please do double check. Don't trust me. You have to please check. Yeah, so if you look at CFA, yeah, exactly.
Oh, wait.
It's a bit hard to look at, but yeah, all of those things should be inside this stack bars.
Shall we stop using private? Or because it seems to me that we are kind of randomly choosing private or internal.
That's my bad. That's not good.
I would say to remove one cognitive efforts, just because there's no way to test private functions in the test framework. In any of the test framework, right? In Foundry, you would inherit a contract and then test. So one way is to say, okay, if it's private, you say you don't intend to test that function, which is a weird thing to say. So instead of having that consideration, you simply say we'll just make everything internal and private is not a part of consideration. That'll be one approach going forward, but we don't have to do such cleanup just for the sake of it. We do lazy cleanup when we need a tester functioning, not through the external fuzzing, but it's through the internal function fuzzing. Then yeah, we change it. But when you do new code, probably just do the internal one. I think that's what I do nowadays, just put internal in Solidity.
New CTX equals CTX. I guess it doesn't really matter where it's done, early or late. buffer. So first it does. First it makes the liquidation payout. And the liquidation payout, it does this. And then it does. Does this make sense in the liquidation case?
Yeah, we do similar things with CFA. So the adjust buffer shifts the buffer delta from the person getting liquidated to the pool. And if you see FA, you also do that.
Wait, the just buffer, it's not a just adjustment stream, it's a different thing, right?
Yeah, they're two different things.
So the adjust buffer, how is that done in the CFA? Is it? I'm trying to understand the difference between the two here.
All right, yeah, so in the CFA, we don't actually do it in the make liquidations function, and I guess we're not doing that in the GDA either. It happens after, so if you look at like delete flow.
Yeah, it's afterwards.
Yeah, it's done in like change flow to add or change flow to non-add, so it's done in change flow, I believe that function handles that.
Well, is there anything you could think of here which could be dangerous? We don't have overflows, etc. anymore in Solidity. Yeah, I guess we don't need to go super detailed in this one.
This function, right? How it gets so big? Let me think of it. Like just buffer. That's GDA. So in future, if you want to use this on the token for lambda, is it mostly for storage thing or no way? This is kind of okay. So you do read storage. And is there any pure logic and extract out to make it a code? Double check. The only thing is like it will like if you so you query the minimum deposit and the on-prem system or something, it will include latency in like every request that we need to consider. Because this part is like somewhere else, like not in like a local system. This latency will include in like every request or like for lambda it's 5 minutes, but every 5 minutes. Yeah, mostly really about storage investment, right? So a lot of boilerplate about reading the story, reading the governance and story. So the theology is probably very trivial. Somewhere I can't follow it. Theology. Multiplication, right? That's a formula. That's it. New flow rate multiplied by liquidation period. That's all. One line. Yeah. Yeah. Maybe the code highlighter could be say, hey, these are the theological. You highlight the line with light shades of green. All other become like red. Yeah, visually separating, where are the boilerplate you have to do just to get things going, and where is like core main logic. And if you have code largely interleaved, then probably means a little bit messy. Maybe that's a visual way of telling you if the code is how the code is organized, and you can judge for save it.
So this is basically another shift after having a shift here.
The make liquidation payout shift is inside of the token, I believe. Just to double check. Whereas the shift inside of the address buffer is this new universal index data shift. Thinking now if it will have a weird. No, I guess you might have like a negative balance in your token agreement. So
and then it's again the non-liquidation case.
just heads up, I have to bounce in 5 minutes. Other meeting.
Yeah.
Maybe we can do one more session on this, I think, next week, but for maybe just 1 hour. Or maybe just 1 hour. Yeah, what do you guys think?
Yeah, we can have as much additional discussion session.
Okay.
Maybe after the daily, we can do that. Some of the
Okay,
smart
yeah.
sessions anytime.
Did we cover all entry points?
We also
changing?
I think we've done distribute flow. So in this function or in this contract, yes, but we also have Superfluid pool as well.
Yeah, exactly. So
I think the numeric, so there are a couple of things, right? So naming convention, numerical accurateness, all those, so the fuzzing could help a lot. But things like permission control, re-entrance, or those kind of things probably worth more manual checking, right? But it's fairly big chunk of stuff, so it's needs to warm up also.
That's for those auditors.
Yeah, I don't know how they can audit this. Just trust the test, right? So let's just focus on writing tests, black box, Yeah, but if the test is not enough because
They don't poke it.
They will. I mean, it's not easy. We would hope for the post-hoc formal verification, but when the contract gets too complicated, it just doesn't never terminates. Proof by correctness by construction needs a filter to make. So it's there's no silver bullet. Damn it! It's 2023. There's no silver bullet still. What have we done? Too much money in ZK.
If you don't see what's on happens.
No need to change anything here.
Yeah, I have to dip, guys.
Yeah.
Sorry.
Okay. Thanks. Good stuff. Yeah.
Thanks, guys.
Bye.
thanks, bye.
Bye.